Hello, today we will create a game. As you can see, it is running inside the terminal. You are probably familiar with it. I mean, you probably saw a variation of this game before. I did not look up the exact history of this game, and that's on purpose because I wanted to work from my memory. I just wanted to capture enough from the game mechanisms to make it fun and a bit recognizable. And I think I achieved that. So this was good enough for me to capture it. And I close myself into the room now. So the main idea of the game is that your character, represented by this @ sign, is a miner who is looking for gems or gold underground. Those are represented by the $sign in this game now. And we can go through, let's start it anew. We can go through the earth and create tunnels in it. We can go through these walls, and we can go through these rocks. The rocks can fall on our heads, and let me show that, and then we die. In order to win the game, we have to reach the exit and collect enough gems while we are going there. Currently, there are no limit. You can always reach the exit. So this is the win, and then you could go to the next level. And usually there is also some enemies. They are pretty dumb. It's easy to implement that, but I did not do that. So that could be something extra for you. As usual, I will share the whole code on GitHub below the video, so you can take it and expand it. The main idea for this video was to showcase what the terminal is capable of, because this is not apparent how to implement such a thing. But that would have been so boring that, I mean, just talking about the terminal, so in the end I created a game for it. And I think it's not that boring anymore. The choices I made today is that you will need nothing else, just a C compiler. We will not depend on anything else, not even things like the cursors library, which would be the natural choice for something fancy in the terminal. Let's jump to it. How can we create a game in a terminal? Let's go over the capabilities and limitations of the terminal as a device for a game. So for a game, we obviously have to display some graphics. The terminal is obviously very low resolution, which is fine. This just limits the type of games we can use there, but we can play with the ASCII characters. We can think of them as either subpixels or textures on those big low resolution pixels. So we have a bit more. We don't have a full control over every pixel on the screen, but we have something in our toolbox. Okay, what else? It can display colors, both foreground, meaning that the character itself, we can change the color of the character itself, and both the background color of the full position. Now, input handling, that needs a different section. So how does the input handling normally works in a terminal? It is by you type in a full line, then you press enter. So that is something called canonical mode. Canonical input mode is line based. Until you press enter, the program does not get anything. This is not good. This works only for a few types of games, like adventure games where you can choose, like typing in, I choose option 2 now and press enter. But otherwise this is not working. But there is something called non-canonical input mode, where there are 4 types of these actually. We will see this in detail a bit later, where we can get all the characters that are being pressed. well, we basically have more control over input. This is what we will use. There is also a third one called raw input mode. We won't use this one. Okay, so this one is pretty critical. There is also another quirk of the terminal is about echoing, which means that when you type in something like this, that it will immediately be displayed at the moment where the cursor is, before your program gets the input. Now that's not good. We want full control over displaying what we are displaying. So there is a way to turn off echo. Some nuance here when we start optimizing the rendering part is that we can move the cursor's position. We can move the cursor's position freely, and that's a very, very good thing, because if for example only your character moves on the board, then we can during a render step we can only update those two places. So the one where it was previously, to clear that pixel, and the one where it moved. That is nice. Otherwise, we would have to constantly redraw the whole page. Okay, what else is needed for a good game? Sound and music. Well, sadly, I don't think that will work. Well, there is obviously the terminal bell, but let's just forget that one. Okay, what is in our toolbox? How can we control these things I talked above? One of them is something called the Termios interface. We will look at its main page. It's a bunch of functions and structures. We will use a very tiny bit of that. We will use that to turn off echoing and turning on the non-canonical input mode. We will see this in detail a bit later. The other one is the so-called ANSI escape codes. I will give quickly a Wikipedia page about that. There are many. And instead of going over all of them, please open the Wikipedia page, and you can get a hint of how many things you can control. But let me just quickly copy paste a bunch of them that we will actually use. Now this is a lot. So this is how we set the foreground color, and this is an example that you can copy paste into the terminal itself to try it out. So think about them. Let's break this down. These few characters, it's just mean that this is the escape key, nothing else. This is a literal left bracket. Some quirks, and these for these two numbers means that we are changing the foreground color. You must read these together. Contrast this with the background color. The only change here is that this is not 38 but 48 now, and then we can send various parameters to it divided by semicolons. So this expects an RGB color from 0 to 255, and we close it with a character M. Now when you print these to a terminal, you send these characters to a terminal. Nothing will be printed on the screen. You just turn on this mode, that now the foreground color is like that, and the background color is like that. Here is a bunch of other things, like moving the cursor to XY space, XY position. This is again the escape and the left bracket, and then in the opposite direction of the coordinates and the big H. Again, when you print this when you send these characters to a terminal, nothing will be printed. Only the cursor will be, so this will be interpreted. The cursor will be moved to that position. And similarly, always an escape and the left bracket and this is the code for cleaning the screen, hiding the cursor, showing the cursor. Maybe I will show quickly the hiding cursor and show cursor. So we will leave this. Okay, now so after this our cursor should be gone. So here is my cursor as I'm moving around, and now it's gone. I can still type in, but it is gone. We can get it back by, I think it was H. Yes, and now we got it back. And if you want to change the foreground color, that was 38.2, and now it expects us RGB. So maybe make it very red and just a little green and little blue. And we have to end it with an M. And now we can send a string here. Let's call it red. And now we see that it printed out red. Please be aware that my terminal actually clears these colors after the program ended. So just pressing enter will clear the color. It might not be the same for you in your terminal. In order to clean anything before is just send an empty call this function basically. And but you don't see anything on my terminal. But if everything is red after this line for you, you can get rid of that, turning everything back to default by this one. Yeah, maybe I will add this to the notes as well. Reset colors. Okay. So let's take a look at the Termios interface. Now this is something huge. It has many things that we don't need, and this can be a bit overwhelming. I don't want to start reading it. We will jump straight into the very tiny part that we will use, which is the non-canonical input mode. This is the section. As you can see that normal in canonical mode input is made available line by line, which is not working for us. In non-canonical mode, input is available immediately. Now, still there are 4 types of that, and these are decided by these 2 variables when you set these things in a Termios struct. At first, I actually started to play with this, which is called read with timeout, because this made sense. Anyway, let's take a step back and think about what kind of input we want to handle. So obviously, if the player starts pressing the arrow keys, then in a game loop, the game loop will run like 10 times per second, and we want to immediately capture that. And I think that can be done with any of these modes. But we also need to support when the player keep pressing, for example, the down arrow key and doesn't press anything, just keeps pressing it. What I found out to work the best was actually the polling read mode. Okay, I just wanted to show quickly this page. I really don't want to go into details because we are using only turning on the non-canonical input mode and turning off echo. The final code will be many lines. And that posed a challenge to me how to present this, so you can also follow it along with me. And what I came up with is to divide the code into multiple stages, basically how I created it, and build up the game feature by feature. At every stage, we will have a working code, a working game which does something, but we will keep refactoring parts of it, and this is how a normal code evolves. And obviously, when we stop at the final version, that can still be improved, and you can take over after the video. Just grab the code from GitHub and you can add things to it. So what will be in stage 1? I want to handle, obviously, turning on non-canonical input mode. and also turning off echo. But I want to do this immediately very nicely, meaning that we will implement a proper reset on exit, which means that both for normal exit and abnormal exit. What I mean by this is that, for example, if we get a signal, for example, we press Control C on the keyboard and we get a signal, then we still want to not leave the program in a way that the terminal after it is broken, like discolored or it's full of garbage. We want to handle this already in the stage 1. We will have a very rudimentary game loop. What this will actually do, we will grab the arrow keys as input and print them out. That's all it does. So there is no echoing, which means that we don't see anything. You press a different button, nothing happens. We care only about the arrow keys, and we will literally print out like right, which means that we press the right arrow key. We will start with a couple of includes. We will use these in all the stages. Then let's create a skeleton in pseudocode of the main function. So we will have something called configure terminal to set up the non-canonical input mode. Then we will enter a game loop. Then we will read the arrow keys. Then we will print them out. Then we will sleep 0.1 seconds. This is not real code, this is just pseudocode. So this is the idea for stage 1, and now let's flesh it all out. Here we will take a copy. We will get the existing attributes from the Termios interface, and we will save a copy of it. This way, when we will reset the terminal on exit, we will be able to set it back everything as it was before. And for this, of course, we need some static variables. With these two 0, flags, we choose the first method of the 4 non-canonical input mode, as we discussed before. We will use polling read. Okay, so a couple of things. Here we finished setting up the non-canonical input mode and turning off echo. And the next line, we are using an ANSI escape code to hide the cursor, that what you can see running around now. And another line, we set up a function that will be called when we exit the program normally. We call either exit or we run out of the main here, and C will call exit for us. This handles half of the cases how we can exit the program. Of course, we still have to handle like signals. So here in reset terminal, we are resetting every color changes, even though we don't do any such changes yet. And we will show the cursor, and then we reset the old Termios flags. Okay, so this part is done. Now let's move to the reading input. We need a way how we can grab the arrow keys from the terminal. I'm using 4K because I think that's the maximum buffer that is stored in the terminal. So this final key, we will store it as an integer. And here is the logic how we read them up. Yes, so why every 3? Let me implement something else first. This code called read key, and then I will talk about why we are stepping every 3 characters in this. We will get back to this. So the reason why we are reading 3 characters is because this is how the arrow keys I can be parsed. This is similar magic as the ANSI escape codes. There is really nothing to learn here except if you know the codes, then this is how you can parse it up. So the arrow keys are stored on 3 characters, and that's why we are going over the input we read up by 3 characters. Now what happens if the user presses like a character like A, which is stored on 1 character in the same loop, and then the user presses an arrow key as well? Well, our offset will be wrong here. So that's what I am referring here, that yes, this is not perfect code, but we don't care. I mean, if the player mistyped, this will be corrected in the next frame anyway, which is not very perceivable by the end user. Well, some users will notice it, but I think this is fine. We want to handle the optimal case because the optimal case is super common. So on the next frame, we will have a new empty buffer, and if the user presses arrow keys, then it will start at the right offset. Now, why are we storing only the last offset? It's because we basically don't care. If the user presses too many arrows in the loop, we will handle only the last key. This is a decision, and I think this is the only reasonable decision. Also, this handles the case when the user keeps pressing the button and we get like 10 right arrow keys. We care only about the last one. We will not buffer it up and store it. We throw away every other key, so we care only about the last valid read key. Okay. Now we need a way to print it out. That sounds easy. So we already encoded how we wanted it with 1, 2, 3, 4, or sometimes 0 if the user didn't press any button or pressed something else, and then we just print it out what the user pressed. So far it looks okay. Now we will do a sleep. For this, we will use a nanosleep system call. The nanosleep system call requires 2 parameters, and the 2 parameters are time spec structs. So why 2? Because the nanosleep, every sleep system call can be interrupted, for example, by a signal. And then, if it was interrupted, and then in this second struct called RAM, we will get back that how many. So let's take a step back. So we ask for 0.1 second sleep, and if we get interrupted by 0.01 second, then the RAM will have 0.09 second. So if we just take what's in the RAM when we got interrupted, then we can sleep again as much as we wanted originally. We will not use that here because we don't really care about that, and there will be no signals. I mean, if the only signal we will care about will be Ctrl+C, the SIGINT signal, and if it's called, then we will handle that differently. We will exit. Okay, I think this is enough to test. Let's compile it now. Oh, compile. Let's run it. Yeah, it is working. All the letters I'm pressing are recognized correctly. Now I will keep pressing the down arrow key. Yeah, it is working, and now we will exit. And as you can see, I exited by pressing Ctrl C, and our cursor is gone. So let's fix it. So we have this reset terminal. Temporarily, let's add the printf call here. Let's compile it again and see what happens. So I'm doing this, and I press Ctrl C, and it was not called. So let's add this a signal handler for this. So here we configure terminal. So we can call reset terminal here on that signal. And we actually want to exit correctly. So we don't want to do anything else. And one way to do this, to get back the original handler, is like this, that we set it back, the signal that we are handling now, we set it back to the default handler. And we raise it again. Okay, let's try the game now. Again, it works. Yes, we see the at reset terminal line, and we got back our cursor. Now this is nice, but this is actually not correct signal handler. So a signal handler, I don't want to get deep into this now, but for example, it can call only a few types of system calls and functions, and printf is not one of them. So in this code, let's be clear. This is perfectly okay, but I don't want to promote bad signal handlers, so I will fix it now. Let's create something called exit loop. It's an integer. So instead of this, we will just call exit loop equals 1. And we will not exit immediately. We just turn that on. And here we are not looping on 1, so true. Let's call exit loop. Like this. Okay, try this again. So the signal handler only just flips this integer, the exit loop that we use as a boolean. Okay, it complains because we don't use this anymore. I don't want any warnings. Oh, we exited immediately. Static int. Yes, because I am not looping correctly. Okay, the game still works, and now I will press Ctrl C, and it exited correctly. Okay, let's clean up if there is anything else. I will remove these lines. Keep as few lines as possible. And I think we achieved everything we wanted in the first stage.